we always start by factoring, because that's going to tell us non-permissible values and help us with a bunch of things. Notice in A, the bottom can factor, it's a difference of squares, x plus 2, x minus 2. So what are our non-permissible values? X can equal negative 2, and x can equal 2. Since none of them cancel out, those will all be asymptotes. I'm going to start abbreviating vertical asymptotes as VA. Are you okay with that? So our vertical asymptotes are x equals 2 and x equals negative 2. To figure out our horizontal asymptote, we look at the highest power. Highest power here is x squared. We have 1x squared on the bottom and 0x squareds on the top, which simplifies to 0, so we do have a horizontal asymptote. If we have a horizontal asymptote, we're not going to have an oblique asymptote. So we don't even have to check for our oblique asymptote. And now we can go and set up our graph. So negative 2 and 2 are our vertical asymptotes. And at 0, we have our horizontal asymptote. So now we go back to our original equation, see if we can find x-intercepts and y-intercepts, because we're going to need to plot some points, and those are always the most important points to start with. Remember, y-intercept, plug 0 in for x. Can you see that you're going to just get 1? You'll get negative 4 divided by negative 4, which is 1. So we know that when x is 0, y is 1. And for our x-intercepts, we want to plug in 0 for y. Again, that's only going to happen. Y is only going to be 0 when the numerator of a fraction is 0. So our only y-intercept, or sorry, only x-intercept is at x equals 4. So again, we have a function where we have a point on our horizontal asymptote. For here, now we need to have some points in this section. We've already got a point in that section. It has to go up towards the asymptotes, because if it went down towards the asymptotes, we would have found more x-intercepts. And since we only found one x-intercept, that tells us that section has to go up. If we want to know what's happening when x is less than negative 2, we're going to have to plug in a value. If I plug in negative 3, can you see that I'm going to get negative 7 on the top? Negative 1 here, negative 5 there. That simplifies to negative 7 over 5. So if I plug in that point, negative 3, negative 7 over 5, that's in this section, so I know this part of my graph has to look like that. And then with 4, 0, I need to find something in this section when x is bigger than 2, and I need to find a value on both sides of x equals 4. So I'm going to plug in 3 first. When I plug in positive 3, I'm going to get negative 1 on top. This is going to be 5. This is going to be 1, so I get negative 1/5. And when I plug a value bigger than 4, when I plug in 5, 5 minus 4 is 1. 5 plus 2 is 7. 5 minus 2 is 3. I get 1 over 21. And so what's going to happen is this graph is going to go through and then approach my asymptote afterwards. All right, we'll finish up with B. First of all, factor it. X plus 2, x minus 2, difference of squares. X plus 3, x minus 3. Non-permissible values are just when you divide by 0, so be careful not to include 2 and negative 2. The only thing that's not allowed is 3 and negative 3. And so that makes our vertical asymptotes x equal 3 and x equals negative 3. Nothing cancels out. There's no holes. If we look at the highest powers to find out if we have a horizontal asymptote, the highest powers are x squared on the top and we have an x squared on the bottom. That simplifies to just 1. So we have a horizontal asymptote at 1 and we have no oblique asymptotes. So now if we were going to graph this one, at negative 3 and at x equals 3, we'd have asymptotes. We'd also have an asymptote at y equals 1. Is it easy to find our x-intercepts? Yes. They're at negative 2 and positive 2, because that's the only place our fraction, the numerator, would equal to 0. Is it easy to find our y-intercept? Yes, plug in 0 for x, and you're going to get negative 4 over negative 9, which is 4/9. So we can label those points. That is all in this section. So we know that this section has that general shape. We still need to find things outside of x equals negative 3 and above x equals positive 3. Just table of values. Start with negative 4. If I plug in negative 4, this would be negative 2, this would be negative 6, this would be negative 1, this would be negative 7. I'm going to get 12 over 7. And because that's in this section, I know my graph looks like that. If I plugged in positive 4, I'm going to get 6, 2, 7, 1, which is also 12 over 7. And that section towards the asymptotes would look like that. Questions you can do for this one are 9 and 10.